Hi everyone. Today we are going to see working principle of DC motor. Before getting into the topic, let us know what is DC motor. A DC motor is a electrical machine which converts electrical energy into mechanical energy. What are the examples of DC motors? The robotic drives, the paper mill machines, and other etc. Here what happens is it converts the electrical energy and do the mechanical energy which is required according to the application. Coming to the working principle of DC motors, let us know the construction of DC motors. We have seen the construction of DC generators. It is slightly similar to the DC motors. What is the difference between DC motors and DC generators? In DC generators, what happens is it converts mechanical energy into electrical energy. The constructions includes yoke, which I have seen in DC generators. It is similar. Let us see. It consists of yoke, pole shoe, pole core, field winding, and we have seen the rotating part, that is armature, which consists of armature conductor at periphery. And we also seen the DC supply which is given to the field coil as well as the armature. But in DC generator what happens? We are going to couple the shaft to the prime mover, that may be IC engines, wind turbine, etc. But in the DC motors we are going to supply to the armature. In commutator, in the DC generator, the commutator works in like it converts the DC, the alternating current into DC current. But in the DC motors, it is vice versa. What happens is it converts the direct current which flows to the armature through brushes and which is connected to the commutator. This commutator will convert DC into AC. Okay, these are the simple construction of DC motors. Now let us see the working principle of DC motor. The working principle of DC motor consists of like when a current carrying conductor placed in a magnetic field, it experiences a mechanical force. What this statement says. For example, we have a conductor. This is the conductor. We consider this as a conductor which carrying a current I, which experiences a magnetic field, that is the mechanical force that has been applied, which is given by F is equals to BIL newtons. Let us see how it works. When a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. The flux is created by a field winding. How it is created by a field winding? I have already said, when you are exciting the field coil, the magnetic field flows from north pole to south pole. That is where the flux will be generated, right? This we have seen in the DC generator. It is similar in the DC motors. But the difference comes is the armature winding. The armature winding plays a role of current carrying conductor. Here we are going to supply a current to the armature conductors. Coming, let us see the how it really works, how this is going to work. Now we are having a conductor, right? We are having a conductor which is placed between a magnet's north and south pole. Here the conductor, this is the conductor. Here the conductor carrying current inwards. Since it's carrying current inwards, we are marking into. Understood? Here we having a two magnets, that is we have two poles, north and south poles. Since we have excited the field coil, the magnetic field flows from north pole to south pole, which is shown in this arrow mark. Later, when you supply current to the armature, what happens? The conductor which is carrying current, if according to the thumb rule, what does the thumb rule says? When you are carrying a conductor, the thumb indicates the direction of current. This is the conductor, this pencil is the conductor. Let us assume this pencil as a conductor. The thumb indicates the direction of current, and this four fingers indicates the direction of magnetic field. I repeat, the thumb indicates the direction of current, and these four fingers indicates the direction of field. In this, we are assuming that conductor is carrying a current inwards. Since it's carrying current inwards, what happens? This forefinger indicates the direction of the field created by the armature conductor is in clockwise direction. The direction of field created by the armature is in clockwise direction. So what happens? So the field created by the armature will be in clockwise direction. So this two field, what you are seeing, right? This will be addition of two fluxes. This will be the addition of two fluxes, and here the arrow mark shows, right? Here the one field which is created by magnets, another field which is created by armature conductor. They cancel, right? Here they are cancelling, the cancellation of two fluxes, right? So after cancellation and addition of fluxes, the field flux will be formed. Here we are getting the gathering of fluxes. This is the direction the gathering of fluxes has been seen, right? This is the direction of the gathering of fluxes has been seen. Where the weakening of fluxes, we can see minute fields are being present here. This is due to the cancellation of two fluxes. And what is the, well, how we get in the direction of force? Yes, the direction of force is always experienced from high flux density. The direction of force is always experienced from high flux density to low flux density. I repeat, the force is experienced from high flux density to low flux density. Hence, we get the direction of force in this way. This is the high flux, this is the low flux, and this is the direction of force. When all armature conductor placed at periphery experience this force, which leads to twisting torque. Right? What does this statement means? This statement means when the current is supplied to the brush, this brush, that is the DC supply, will be converted into alternating current. This alternating current will be supplied to the conductors. When this conductor carrying current, using a thumb rule, we are going to get the direction of the force. I repeat, when a DC supply is supplied to the armature, how it is supplied? Using the brush is connected to the commutator, which converts DC supply to the AC, that is alternating current. This alternating current, the current carrying conductor, that is armature conductor carrying this current. Using thumb rule, we are going to get the direction of force. When this forces gets added, when all armature conductors placed at periphery experience this force, which leads to twisting torque. Hence, when this all conductors experience force, what happens? If this is F1, this is F2, and this is F3, they all experience a force. And the armature conductor rotates. This is how the armature conductor rotates. This is how it is converted electrical energy into mechanical energy. Now, how you are going to get the, what is the expression? What is the expression of force? the magnitude of the force experienced by the armature conductor is given by F is equals to BIL. What is B? B indicates the magnetic flux density produced by field winding, that is in form of Weber per meter square, where L is the active length of the conductor, that is meter. I is magnitude of the current carrying conductor by the conductor, amperes. Current carrying by the conductor, that is nothing but I. Now, direction of rotation is determined by Fleming's left-hand rule. Direction of rotation is determined by Fleming's left-hand rule. What does the Fleming left-hand rule says? Let's see what does Fleming left-hand rule says. If this is if you placing your fingers, that is thumb, forefinger, middle finger, perpendicular to each other, here the first finger, that is the forefinger, indicates magnetic field, and the middle finger indicates the direction of current, and this thumb finger indicates the direction of force experienced. If in this case, if you're placing a magnetic field in this direction and the conductor is placed inwards, we get the force this way. That is what we have seen in this diagram. That is, when the magnetic field is flowing from north pole to south pole, when the conductor is carrying current inwards, right, this is inwards, the force experienced, that is the thumb, will be in this direction, that is right side. Like I show it again, this is a middle finger which shows the current, this is the forefinger which shows the magnetic field, and this thumb finger which shows the force. This is how you get the force. I hope you understood this concept. Once again, you see the video. If you have any doubts, please comment below. Thank you.